can take it. So what we discussed was energetics. What we discussed was we were talking about the Hess law, or I told you this was one of the most difficult questions that you're going to face in AS, and I told you that there were two ways of solving this. There was an easy way of using formulas, which is conditional, does not always work, but there's a difficult way which always works. So that's your backup. We're doing the first one. So drawing the Hess cycle, the Hess law stated that the enthalpy change of a reaction is the same no matter which route is taken, which path is taken. So if you're using carbon and oxygen and you're trying to make carbon dioxide, it doesn't really matter how you make that. As long as you end up with carbon dioxide, the enthalpy change is going to be the same. So no matter which path is taken. So yesterday we did two paths. We did, you can make carbon and carbon dioxide when you react carbon and oxygen directly. Burn carbon and excess oxygen, you get carbon dioxide. That's path number one. And the second one was, what you could have done was that you could have reacted carbon with only some of the oxygen and make carbon monoxide, and then convert that carbon monoxide and react it with the remaining oxygen to form carbon dioxide. So that was your second path. You could have taken this route. So the enthalpy change of the first route and the enthalpy change of the second route is exactly the same. So path number one had the energy change delta H1. Path number two consisted of two reactions. The first one was that you reacted carbon with half oxygen to form carbon monoxide. Then you reacted carbon monoxide with the remaining oxygen to produce carbon dioxide. And that was enthalpy change 3. So delta H1, the blue one, was equal to the second path, which is delta H2 plus delta H3. So the advantage of making a Hess cycle is, or having multiple paths is, you can have a relationship between the enthalpy changes of 3 completely different reactions. And if you know the value of 2 of them, then automatically you can, by using the equation, you can figure out the enthalpy change of the third reaction. So if any 2 are given, you can figure out the third enthalpy change. So 3 reactions completely, and let me state the 3 reactions. The 3 reactions that you had were these reactions. I'm going to write those reactions over here. There were 3 seemingly unrelated reactions which were connected together by drawing a Hess cycle. The first one was that carbon reacting with oxygen to produce carbon dioxide. That was your delta H1. Here you had a second reaction, which was, so that was delta H1. Then you had a second reaction, which was that you could have reacted carbon with just half oxygen and form carbon monoxide. So that was the enthalpy change 2. Or you could have done was that you could have reacted carbon with carbon monoxide with half oxygen and turn it into carbon dioxide. So that was your delta H3. So most of the questions are going to be like this. Okay, what they'll do is they'll give you 3 reactions, like the ones over here. They'll give you 3 reactions. They'll give you the enthalpy change of 2 of the reactions, first one or the second one, and they might ask you the enthalpy change of the third reaction. So you would have to figure out a relationship. You would have to draw a Hess cycle and figure out the relationship that exists between delta H1, delta H2, and delta H3. So I told you drawing the Hess cycle is like solving a puzzle. Sometimes it would be very easy for you. Sometimes, no matter how you try it, I mean, you would not be able to connect the 3 equations together. So remember, if you have the Hess cycle, figuring out the relationship is easy, but drawing the Hess cycle is tough. Like if you're given these 3 reactions, it's pretty hard to actually figure out how to connect the 3 reactions together. So we're going to practice that. So it requires a lot of practice. But is this clear? Okay, one path is equal to the other path. That's simply Hess law. Is this clear, everyone? Yes or no? Is this clear?
Yes.
Okay, so we're going to directly move towards questions, solving questions. So remember, the whole idea is some reactions would be given. You connect them together and draw a Hess cycle. And then you figure out the relationships between the 3 enthalpy changes. Once you figure that out, 2 of them would be known. You'll find the third one. So we're going to move towards questions. So this one. Just a second. Okay. So starting off with the first question, which is over here. Now the first one is kind of easy. I would need a calculator for that as well. Just a second. You can make sure you have a calculator for this. So starting with the first question, now they've drawn a hypothetical Hess cycle, which is that there's some R that changes into S, and that S changes into U, and so on. So he's saying the enthalpy change for the transformation U to R. So you're going from U to R. So U is over here and R is over here. I said yesterday we also discussed one very important point, and that was, I wrote it somewhere, which was this one. If you go in the opposite direction of the arrow, the sign of the enthalpy change would change. Like if you're going from X to Y, the enthalpy change is plus delta H. If you're going in the opposite direction, the reverse direction, the sign of the enthalpy change would be the opposite. And if it's plus, it would become minus. If it's minus, it would become plus. So going back to this question, you have to, that's your starting point. And this is, he wants to go till R, U to R. So the first thing is, this is the route that he's going to take. So this arrow, its enthalpy change would change because you're going in the opposite direction. So this would be minus 92. And this arrow, you're going in the opposite direction. So that would be, its sign would change as well, and that would be plus 134. So the first option was U to R. Is it coming out to be 42 or not? So U to R is, you follow the arrow going from this to this, that would be minus 92 plus 134. And I think that would come out to be equal to 42. So the first option is correct. ठीक है, ये clear है? Is this clear? Mahad, is this clear, right? Sidra?
Ji sir.
So that's the first option, and that is fine. Then he's saying that T2S is endothermic. So let's rub this off. But let me choose another marker. T2S. So you start off at T, and you have to. So this is your end. This is where you have to reach. This is your starting point. So kahan se jana padega? You would have to go all the way in this direction. So you would have to go all the way in this direction, and the first thing is you don't have to change this. This is minus 75. So this arrow is fine. So it's minus 75. Okay, just focus on the blue ones. And this arrow has to change. You have to go the other way around. So it's going to be minus 92. So your blue arrow is basically T2S is minus 75 and then minus 92. So minus 75 and it's minus 92. So it can, I mean, it's obviously not endothermic. Okay, it's going to come out to be negative. So that means this one is wrong. So option 2 is wrong. And then we can move towards option 3. Let me rub kar lete hain. So let's rub this off, and 1 second. So the last one, the enthalpy change R to T. So you have to go from R to T. Now there are 2 ways. One is the direct way, but you don't, I mean, you have no idea what that is. So the other one is the other, I mean, remember there are 2 paths. So that's your other path. So let's go figure out. So it's going to be minus 134. Okay, then you have to follow this arrow, S to U. That is plus 92. And then you have to switch the direction of the last arrow. That would be plus 75. So R to T is minus 134. And it's plus 92. And then it's minus 75. Okay. So Oswald, the answer comes out to be plus 33. So iska matlab hai ke the last option is also incorrect. So only the first option was correct. I said, remember in your exams, they've actually finished this 1, 2, 3 type questions. They still give those questions, but 1, 2, 3 have a specific key, which is K. A stands for 1, 2, and 3. All are correct. Even in O levels, you got these questions. But a key would be given. B stands for 1 and 2 are correct. C stands for 2, 3 are correct. And D stands for 1 only. You don't have to memorize the key every time it would be given with the question. But in the worksheet, it's not written, so I've written it over here. I say, your question, is this clear? Sanu, clear? Hania, is this clear?
Yes.
Okay, so I'm going to attempt the easy questions first. Let's pick this question. So what I'm going to do is I'm going to take this question. Okay, there's no space for working. So let's go. Where's our board? So let's solve it here. So let's try and solve this question. So remember, you have to draw the Hess cycle. So this is the first question when you have to draw the Hess cycle. The equations are given. The equations are kind of by looking at the equations, they don't, you can't find any connections, but you have to connect all the equations together in the form of a cycle. And they're asking you to find the enthalpy change of this particular reaction. So this is the enthalpy change that you have to figure out. So what we're going to do is I'm going to first write the equation. It's carbon dioxide, which is gaseous, and it's reacting with H2, which is also gas. And form क्या what is getting formed is carbon monoxide, which is a gas, and H2O, which is a gas as well. Anyways, that's your equation, and you have to figure out the enthalpy change of this reaction. They're asking, okay, what is this? Okay, what is the enthalpy change of this reaction? So remember, one path is equal to the other path. So that's your starting point. And that's your end point. So you want to start here, and you've got to end here. So Hess Law stated, no matter what route is taken, no matter what part is taken, the enthalpy change is going to be exactly the same. So what you're going to do is you're going to create this other path, which at the moment we don't know what that path is, but we're given a bunch of equations, and we're going to use those equations, and we're going to try and create this path. So path 1 and path number 2 are both going to have the same enthalpy change. As long as you are making the same thing, the enthalpy change would be exactly the same. So let's start. Remember, I have to create this other path. I have to sort of link all the equations together. So I have to create this other path. So starting with the first one. Now, very carefully look at the first equation, TK, and remember, it's not that difficult. Very quickly look at the first equation. What's happening in the first equation? Carbon monoxide is turning into carbon dioxide. The energy change that is required for that, turning carbon monoxide into carbon dioxide, is minus 283 kilojoules per mole. So you want to turn carbon monoxide to carbon dioxide. Do you see carbon monoxide anywhere? TK, there is carbon monoxide over here. What I'm going to do is, I'm going to take this carbon monoxide, and I'm going to turn it into carbon dioxide. And I'm going to keep the H2O as it is. H2O is not doing anything at the moment, so I'm going to keep that as it is. So remember the products. I took the carbon monoxide, I turned it into carbon dioxide. This is what the first equation stated. Okay, if you want to turn carbon monoxide to carbon dioxide, it requires minus 283 kilojoules per mole. And let me put a box around it. So is this clear? You clear?
I don't understand it.
Need this one? Actually,
Yeah,
Actually, your first thing to clear, you're looking for this equation, right? You're trying to find the enthalpy change of this. Abni kaise question pucha tha?
yeah, it's me, Mahad.
Mahad. So Mahad, is the first part clear? You're looking for the enthalpy change of this reaction, right? You're trying to figure out the enthalpy change. The whole point is if you're able to figure out this other path and you know the energy change of this other path, you would be able to figure out the enthalpy change of the reaction because the enthalpy change is the same no matter what route is taken. Mahal, is this point clear?
Yes, sir.
So we are given this reaction. We need to find the enthalpy change. So, and they've given us 3 reactions and their enthalpy changes are known. So what I'm doing is I'm doing this thing. I'm trying to create this other path which which leads to the products. So I'm trying to create that using these equations. So one of the equations, think of it that I'm doing the reaction stepwise. I'm trying to figure out certain steps, like what should I convert this into? Then what should I convert this into? And I'm trying to make the products and reach the other side by following these small steps. So the first small step that I saw was that carbon monoxide turning into carbon dioxide. So I saw this carbon monoxide over here in the products, and I decided to convert that into carbon dioxide because the energy change that was required for that is already given. That's minus 283. So what I did was I took carbon monoxide and I turned it into carbon dioxide. And the energy change that is required is minus 283. Water wasn't doing anything in this step. So water remained as it is. Mahad, is this point clear?
Yes, sir.
So I'm going to do the same thing with the second equation. Look at the second equation. You've got hydrogen, and that hydrogen is turning into water, which is liquid. So where do you see hydrogen? I see hydrogen over here. I'm going to do that. What I'm going to do is I'm going to take this hydrogen gas and turn it into H2O, which is liquid. So and I'm going to keep carbon dioxide as it is. I'm not going to touch carbon dioxide. Nothing is going to happen to it. It's not even taking part in the reaction in this particular step. So focus on this step. What did I do? I saw H2. So what I did was I saw H2 and I turned it into H2O liquid. So H2 turning into H2O liquid requires how much energy? That's the enthalpy change is minus 286 kilojoules per mole. Mahad, is this clear?
Yes, sir. It's clear now.
So I've connected the first equation somehow with this, with my original equation. This is the equation. The blue one is the one that I'm trying to figure out. So I've connected the first reaction with this. I turned carbon monoxide into carbon dioxide. The second one, I turned hydrogen into H2O liquid. I saw hydrogen, I turned it into H2O liquid. So I connected the second one. Is this clear so far to everyone else?
Yes.
Yeah. Now let's come to the last one. The last one is you got H2O gas turning into H2O liquid. Now the only thing is, remember I had to create this other path. So the only path, the only missing link at the moment is this one. That's the only missing link. What is this missing link? What's happening in this step? Nothing is happening to carbon dioxide. Carbon dioxide gas goes over there, it's still carbon dioxide gas. So that means carbon dioxide did nothing in this step. What happened to water? Water was liquid and it turned into water gas. So this enthalpy change is already given over here. It's actually water gas turning into water liquid. So I'm going to change the direction of the arrow. So I had water, which was gaseous, and it's turning into water, which is liquid. So that energy change is minus 44 kilojoules per mole. So I've created this other path now. What I did was I saw an equation where hydrogen was turning into H2O liquid. I saw carbon monoxide turning into carbon dioxide. I knew the energy change, and I saw the energy change of water gas turning into water liquid. That was minus 44. So my other path is now created. So the only thing remaining is that's path number 1. And if I just, a second. So that's path number 1. And here's my path number 2. Here's my path number 2, and both paths are going to be equal. Is this clear, everyone? Oswa clear, Hania, Sidra, Mahad, Raid, is this clear?
Yes, sir. It's clear.
Yes.
Achha, so just remember this. This equation was given, and I created this other path using the 3 equations that were given above. Now, the only thing remaining is that I just need to solve this. Okay? Remember, figure out the relationship. This is path 1. Okay? I'm going to call that P1. I'm going to call this P2, path number 2. Both paths, because no matter what route is taken or path is taken, the enthalpy change would be exactly the same. So path 1 is equal to path 2. So path 1 is the enthalpy change that you're looking for. So that's the enthalpy change that you're looking for. And path number 2, it's going to be minus 286. I said then this arrow direction has to change because you're going in the other way. So it's going to be plus 44. And this arrow direction has to change as well. This would be plus 283. So आपके पास answer आ जाएगा, and that comes out to be 41. Are you sure? So ठीक है, 41 kilojoules per mole. 41. ठीक है, is this clear to everyone? Clear? Achha, so even this was kind of easy. You get I mean, you have to somehow figure out this other path, and obviously it's remember, I mean, this is just a 1 mark MCQ, so it's very time consuming. There's a lot of effort required, and you have to be very careful with any sign that you're using, because even if you do everything right, Achha, Misha, it's why is the first given reaction reacting with the end reaction and not the start one? So Achha, that's actually a good question. I mean, I could have actually connected it with carbon dioxide as well. So let me do that. Let's remember, even using these equations, I could actually come up with different steps. The steps could be not in the same order always. So let's I mean, this is the enthalpy change we're looking for. So let's figure out, your question was, why isn't the first one connected to the end and not at the start? So I'm going to connect it to the start now. Carbon monoxide turning into carbon dioxide. So that's what I'm going to do. I've got carbon monoxide, which is gas, and I'm going to turn it into carbon dioxide. And I'm going to keep H2 as it is. So nothing happens to it. Okay, so that is carbon monoxide turning into carbon dioxide. Remember, in the previous cycle I built, I connected carbon monoxide to carbon dioxide at the end. I could have connected it at the start as well. But let's see. Now you're going to get a different cycle, but hopefully the answer would be exactly the same. So this is minus 283. So this one is minus 283. I saw carbon monoxide, I turned it into carbon dioxide. So then what about the other reaction? H2 turning into H2 liquid, H2 gas turning into H2 liquid. So I got H2 gas, and I'm going to turn it into H2O liquid. So carbon monoxide remains exactly the same, and H2 gas turns into H2O liquid. So in this path, the only thing that's happening is nothing is happening to carbon monoxide. H2 gas turns into H2O liquid, and this value I think is minus 280 kilojoules per mole. And the last step, which is H2O gas turning into H2O liquid, that's minus 44. So I see H2O gas over here, I turn it into H2O liquid, that's minus 44. So clearly this cycle and the cycle that we drew previously, they're different. I mean, the steps are different. Or the position of the steps are different. Like H2O gas turning into H2O liquid comes over here. Over here, it comes a lot earlier, like right at the end. Carbon monoxide equation came at the end. Over here, it's coming at the beginning. But hopefully, you're going to get the exact same expression. So remember, there's not one way of making a Hess cycle. For the same question, you can make multiple Hess cycles, but it wouldn't matter. You're going to get the same exact result. तो वो figure out कर लेते हैं. That's one. That's the second one. Path 1 is equal to path 2. So delta H is basically equal to what? It's equal to, you have to change this direction. So it's plus 283. This direction is fine. That's minus 286. And this direction has to change. So that's plus 44. So I think you're going to get plus 41 again. Yeah, so is this clear? Does this answer the question? Is that all clear? Achha, so just remember, okay, it's like there's not one way of making the cycle. The cycle could be upside down. Something could come first. Something could be at the end. So all your cycles can be different because it's arranging the three reactions in some way, in some order, so that you get the product. Starting from here, you connect the steps and you make the product. So it could be the reactions could be not in the right order, but every time you're going to get the same answer. So let's try and do another question. So let's try a slightly more difficult question. Just hold on 1 second. Just give me 30 seconds, TK. Let's try and do this question, this one. Okay, and let me take this to the board as well once again. So let's now remember in Hess cycles, be careful with the moles as well. Okay, remember to take care of the. I mean, make sure you be careful with moles. So what I mean by that is that if there's a reaction, and we already did this earlier as well, that if you have a reaction, like any reaction, let's say NaOH plus HCl and NaCl plus H2O, and the enthalpy change is coming out to be minus 57 kilojoules per mole. So remember, if the moles of the equation double, that means the amount of reaction that's happening is twice as much. So the enthalpy change would also multiply by 2. It's going to be twice as much. It's like if you burn one piece of paper, that would produce X amount of energy. If you burn 2 pieces of paper, that would produce double the amount of energy. So if the moles increase, the enthalpy change value would also increase accordingly. So make sure you be careful with that, TK. Make sure you focus on how many moles you're using. Anyways, this question is about, what is it about? It's about trying to figure out the enthalpy change of formation of iodine trichloride. So what is, by definition, the enthalpy change of formation? That is when 1 mole of a substance is formed, and it is formed from its constituent elements. And the elements must be in the standard state. So the element would be iodine and chlorine. And chlorine is a gas, and iodine over here is a solid. And remember, it has to be 1 mole of a substance. Enthalpy change of formation, by definition, enthalpy change of formation over here is for 1 mole of a substance. Okay, 1 mole ही बनाना है, ठीक है? So from its constituent elements. So this should be half. So now this should be half. And this should be 1.5 Cl2, which is 3 by 2. So they are asking you to figure out the enthalpy change of this particular reaction, which is the enthalpy change of formation. Okay, this is the reaction with enthalpy change that they are looking for. Remember, the states are very, very important. Okay, be careful with the states when you're drawing the Hess cycle as well. So you have to figure this out, and 2 reactions are given. Now, the first thing is, okay, the very first thing is that when you try to figure the enthalpy change, it's very difficult to deal with decimals. Like 3 by 2 is 1.5 decimals, 1 by 2 is 0.5. So it's always more difficult to deal with decimals. So better to convert everything to whole numbers. So it's a lot better to have equations which are balanced in whole numbers. You need whole number coefficients. That makes things a lot easier. So one way to do that is just multiply the whole equation by 2. So if you do that, this would become 1i2, this would become 3 Cl2s, and this would become 2 ICl3s. But your enthalpy change would be double that now. So basically, if you try to figure out the enthalpy change of this reaction, you're basically figuring out the enthalpy change of 2 times the enthalpy of formation. So I'm just going to ignore the so I get rid of the half and the 1.5 because that kind of makes calculations complicated. Anyway, so I'm going to create this other path now. This is my first path. I mean, this is my reactant, and this is where this is my endpoint. That's going to be my product. I'm no longer forming 1 mole because I'm trying to find the enthalpy of formation, 2 times the enthalpy of formation. So let's start. Yeah, clear? Is this clear? So is this clear, Amna?
Yes.
Okay. So enthalpy of formation of iodine trichloride, but 2 times the enthalpy of formation. First step, look at this equation. It's easy to connect this one. Iodine solid turning into iodine gas. So let's connect that. I got iodine solid over here. I'm going to turn it into iodine gas. And nothing, I'm not going to do anything to Cl2, so I'm going to take that as it is. That's not going to change. So anyways, iodine solid turn into iodine gas, and the value for that is plus 38. So that is plus 38 kilojoules per mole. I said then, so I've connected this equation. That's done. Now I have to complete the path. The other one is iodine reacting with 3Cl2 gas, and it forms 2 ICl3 solid. So this is exactly this path. This is exactly this. Okay, you got iodine gas. So you got iodine gas over here, and it reacting with 3Cl2. So you got 3Cl2 over here as well, and then forming 2 ICl3 solid. So that's exactly, so the enthalpy change for this particular path is minus 214. So I figured out my 2 paths now. That is done. So this is path number 1, and that's my path number. So that's my path number 2. I just need to add all of them up. So I just need to just make the equation path 1 is equal to path number 2. So it's going to be what? 2 times delta HF is equal to plus 38 and minus 214. So that's my path number 2, and that's my path number 1. According to Hess Law, both paths are going to have the same energy change. So make them equal and solve. And remember, he did not ask you to calculate for 2 times the enthalpy of formation. So what I'm going to do is I'm going to take this 2 and put it in the denominator on the other side. So I'll be able to figure out the enthalpy of formation now, and that would come out to be kya aa raha hai? Is this coming out to be minus 176 divided by 2? And that I think would come out to be B minus
minus 88.
Okay, that's coming out to be minus 88. So be careful with this. One thing, I mean, the 2 other additional points that we studied that we discussed over here is, okay, if you double the moles or triple the moles or whatever, TK, if I had to do half I2 and half I2 gas, this would have been half as well. TK, so make sure that the enthalpy change is linked to the moles of the equation. TK, if you double the moles, the enthalpy change value would also double. That's one thing. And the other thing is, it's better not to use equations which are balanced in fractions. I mean, making the Hess cycle would kind of become very, very difficult if you do that. So और कोई करते हैं कि let's try. अच्छा मुश्किल बात रह गया. So let's try this. Let's try this one. कि अच्छा space नहीं, I'm taking it away. So let's try this one. Now, in this question, he's asking you to calculate the enthalpy change of this particular reaction. Okay, so this is the one that you're looking for. So that's your, those are your reactants, and that's your product. So you're going to try and figure out this other part now. And you're going to try and figure that out, how to reach or how to form calcium 2 plus aqueous, starting with calcium that is solid plus aqueous minus 2 electrons. So you have to figure this one out. And the enthalpy change values are given for these 2 reactions. There's some values that need to be taken from the data booklet, which I'm going to give to you. I'm going to give you 2 more equations. One is that calcium gas losing 2 electrons is 590 kilojoules per mole plus 1150. I think that's the right. So because remember the ionization energies are given in the data booklet, so I've quoted it over here for you guys. So you're given 3 reactions, these 3 reactions, and you have to figure out the enthalpy change of this particular reaction. So try and create this other path. This is the enthalpy change that you're looking for. You have to create another path using this calcium solid turning into calcium gas, calcium 2 plus gaseous reacting with aqueous, turning into calcium 2 plus aqueous, and this third one. So I'm posting this question in the WhatsApp group. Try and send me the answer. Okay? Do this as a homework because we're running out of time. Try and practice this. Try and create this other path. ठीक है, ये मैं उधर post कर रहा हूँ. So make sure everyone try this. ठीक है? वरना हम कल वैसे ही कर लेंगे, ठीक है? So let's continue tomorrow. Does anyone have any questions with this? ठीक है, we're going to practice some more questions related to this, and then we're going to move towards the formula thing. The formula is going to be very easy. This one is tough, but the formula part is really easy. But it doesn't really apply always. ठीक है, that is conditional. So चलो, let's continue tomorrow then, ठीक है? Okay, everyone.
Sir,
Yes.
you know the questions that I find difficult to answer. Can I send them to you and you can explain them?
Yes, and what you can do is you can sort of collect them, and we can have a live class on them, like after this class, like at 9:30, I'm available. So we can, like, you can send all of them on WhatsApp and we can discuss them, I mean, at this point. ठीक है?
Okay, thank you. Allah Hafiz.
चलो ठीक, okay.
Okay.
Hafiz. नहीं, OSFI A नहीं है. It's, I don't think it's A. I think it's D, ठीक है? तो वो, I'm not really sure, लेकिन working मुझे send कर दो, ठीक है? I'll just have a look. चले, okay, take care, Allah Hafiz.